There's this persistent myth we have about intelligence.
Mhm.
It's something we've carried over from, I don't know, movies, from science fiction, maybe even from our own insecurities.
Oh, for sure.
We tend to equate smart with limitless.
Yeah.
Like, if you meet a genius, a real Sherlock Holmes type, you just assume they can remember everything, process everything, and they never, ever get tired.
It's the mind palace fallacy, right? We have
Yeah.
this vision of a great mind as this perfect, infinite attic where everything is stored neatly and you can just retrieve it instantly.
Exactly. And we've projected that exact same fantasy onto artificial intelligence.
Completely.
We see these models, they pass the bar exam, they write sonnets in Old English, they can code entire applications in seconds,
Yeah.
and we just assume, okay, the brain is perfect, it's silicon, it's digital, so it must be infinite.
But if you actually, open up the hood, if you really look at the engineering reality of these systems, you find something totally different. You don't find a limitless brain. You find a system that is desperately, constantly trying to manage a very, very severe constraint.
A constraint that I think most people don't even know exists. Today on The Deep Dive, we are breaking down the cognitive architecture of AI agents.
Mm-hmm.
And we are going to focus on the one thing that really nobody talks about, the AI's attention span.
Or, as the engineers call it, the context window.
The context window. It sounds so technical, but based on the research we've pulled for today, this is actually the defining struggle of modern AI.
It really is.
The sources we're looking at, they all seem to suggest that making an AI smart is like the easy part.
Arguably.
The hard part
Hmm.
is making it remember who you are 10 minutes into a conversation.
That's the whole game right there. The sources we have on the table today, and they range from, technical documentation on MemGPT to these deep analyses on multi-agent failures, they all point to the exact same thing. The context window is a finite resource.
It's real estate.
It is precious real estate.
Right.
And if you run out of it, the smartest AI in the world, it basically turns into a goldfish.
So our mission today is to explore that real estate. We're going to look at the tricks, the context management strategies that engineers are using to make the AI feel like it has a limitless memory.
Right, the illusions.
We're talking about paging, we're talking about compression, and this really, really cool concept called progressive disclosure.
And then we have to look at the crash sites.
The failure modes. Because let's be honest, that's where the real drama is.
Oh, yeah. Because when these memory management strategies fail, they don't just, stop working. They
Mhm.
fail in these spectacular, really bizarre ways. We're going to talk about hallucination cascades and context drift, things that sound like they're straight out of sci-fi horror, but are actually happening in production right now.
Okay, so let's start with the basics, the brain of the machine. The source material uses a really strong analogy right out of the gate to explain how these agents handle memory. They compare it to a computer's operating system.
Specifically, yeah, the distinction between RAM and disk space. This is absolutely fundamental to understanding something like MemGPT, which is one of the key architectures we're looking at.
Okay, so for anyone listening who isn't, building their own PC on the weekends, let's break that analogy down. What is the RAM in this scenario?
So in a computer, RAM, your random access memory, that's your workspace.
Yep.
It's where all the data lives while you are actively using it. It's incredibly fast. The processor can access it instantly, but
That's limited.
it's limited, it's expensive, and crucially, it's volatile. When you turn the computer off, the RAM is wiped clean. Gone.
It's the top of my desk. It's where I have my coffee, my notepad, the book I'm reading right now, all the immediate stuff.
Yes, exactly. It's the workbench. Now, in
Mhm.
an AI model, the context window, all the text the AI is reading and generating in this very second, that is its RAM. That is the workbench.
And the problem is the workbench is small. I mean,
Yeah.
even when these companies announce 1 million tokens or
Uh-huh.
2 million tokens, it's still a hard limit.
It is absolutely finite, and maybe even more importantly, the more you pile onto that workbench, the slower and more confused the worker gets. Think about it. If your desk is covered in 5,000 papers, just finding the one sticky note you need becomes this massive cognitive load.
You spend more time looking than working.
Precisely. So if the context window is RAM,
Then what's the hard drive? What's the disk?
the disk is external storage. It's
Okay.
databases, it's files, vector stores. It's a place where you can, in theory, store an infinite amount of information, but the AI cannot think about that information unless it pulls it off the disk and puts it onto the workbench.
Okay, and this is the key distinction, isn't it? Because historically, LLMs, large language models, they didn't really have a disk. They only had the workbench.
Correct. If you scrolled up too far in a chat with an early model, that information was effectively gone forever. It just fell off the table. It completely ceased to exist in the universe of that model.
So this architecture, they call it context paging, is trying to solve that. The source material really highlights MemGPT as the pioneer here. So how does it physically, or I guess digitally, how does it bridge that gap? How does the AI know to even go to the disk?
This is where it gets really fascinating and honestly a little anthropomorphic.
Yeah.
The system gives the AI tools, just like we give it a calculator tool or a web search tool. We give it memory management tools. The source specifically lists a function called core memory append.
Core memory append. It sounds very cyberpunk, like I'm updating my firmware.
It does, but just think about what that implies for a second. The AI is processing a conversation. You say something like, hey, by the way, my daughter's birthday is in November, so I can't travel for work then.
Okay. A normal kind of throwaway sentence in a longer chat.
To a standard AI, it just responds, okay, noted, and then it promptly forgets it 50 turns later because the context window slides forward.
Right. It falls off the workbench.
But an agent running on this MemGPT architecture, it analyzes that sentence. It thinks to itself, this looks like a permanent fact about the user. This is a constraint for any future planning. It then chooses to trigger the tool core memory append.
So wait, it's making a conscious choice. It pauses the conversation, takes that specific sentence, and physically writes it to the database.
Explicitly. It offloads it from the fragile RAM to the permanent disk.
Yep.
It is making an active, strategic decision about what is worth remembering long term.
That feels like a massive shift in agency. It really does.
Yeah.
Usually we think of the AI as this passive thing. It just predicts the next word. But here it's acting as its own librarian. It's deciding which books to keep and which ones to, I guess, let go of.
It is self-modulating its own memory. And of course, it works the other way too. The source also mentions archival memory search.
The retrieval tool.
Exactly. So fast forward 3 weeks, you come back to the same chat and you say, hey, I need to book a flight for that conference in Q4. The AI's current context window, the RAM, is empty. It's a new session. It doesn't know you. It certainly doesn't remember the birthday conversation.
It's a complete blank slate.
But the agent is trained to feel that gap in its knowledge. It realizes, okay, I'm booking a flight, but I don't know the user's constraints. So it runs a check. It triggers archival memory search. It queries its own database for keywords like travel constraints or unavailable dates.
And it pulls the November birthday file out of the cabinet and puts it right back on the workbench.
Exactly. It pages the necessary context in just in time. This creates this powerful illusion of an infinite continuous memory. The AI seems like it remembers everything you've ever told it, but in reality, it's just become very, very good at swapping the right files in and out of its immediate view.
It's a magic trick, a really clever one, but it's a necessary one. However, I want to challenge this a bit.
Please.
Because swapping things in and out is great for hard facts, dates, names, phone numbers, discrete pieces of data.
Sure.
But what about the feel of a conversation?
Yeah.
The texture?
You're touching on the texture of the interaction, the vibe.
Right. If I'm having a long brainstorming session with an AI and we're riffing, there's a flow, there are inside jokes, there are callbacks. If that stuff gets paged out to a cold, hard database, does the AI lose the thread of the actual human interaction?
It absolutely can, and that's a huge limitation of this approach on its own. Paging is binary. The data is either on the workbench or it isn't. If the joke from 10 minutes ago is in the database, the AI isn't thinking about it. It can't use it for a callback.
So you lose the continuity.
You can. And this leads us directly to the second major strategy in our stack, context compression. Because sometimes you don't want to file the paper away, you just want to write the same information smaller.
Shrinking the haystack so you can keep it all on the desk.
Precisely. The problem here is chat history. If we talk for 2 hours, the raw transcript is massive. We can't fit it all on the window. But we also can't just delete the beginning of the conversation, or the AI won't know why we're here or who you are.
So what does compression actually do? It's not just like deleting every other word or removing the vowels.
Well, no, that would just create gibberish. The source describes a recursive summarization process. So imagine we're at turn 50 of a long conversation.
Okay.
The system takes, say, turns 1 through 40, the stuff that happened a while ago, and it passes that whole chunk of text to a separate summarizer model. This is often a cheaper, faster AI model working in the background.
So it's like having a little stenographer in the corner whose job is just to take notes.
A very efficient stenographer. That summarizer reads the 40 turns of dialogue, all the hellos, the how are yous, the let me clarify that, and it distills them down into a single dense narrative block.
Can you give me an example? Like if we were to compress the first 10 minutes of this deep dive, what would that summary look like?
It would probably turn, say, 1,000 words of our back and forth into something like, host introduced the topic of AI cognitive architecture and the mind palace fallacy. Expert defined the context window as a finite resource using the RAM disk analogy from MemGPT. Key concepts discussed, core memory append, and the limitations of context paging.
Okay, so it captures the data points, it keeps the skeleton of the conversation.
It captures the informational state,
Great.
but, and here's the trade-off that the engineers really agonize over, it loses the nuance.
It loses the fluff. The source calls it the fluff factor.
Right. But fluff is often where the personality lives. Fluff is where the persuasion happens, where the rapport is built. If the user was angry in the first 10 minutes, but then they calmed down, the summary might just say, user expressed initial frustration.
It just strips all the emotion out. It turns a novel into a police report.
That is a perfect description. It turns the living conversation into a police report. So the AI knows what happened, but it might lose the ability to mirror your tone or understand the emotional journey.
So if you make a joke in turn 5 and the AI laughs,
Yeah.
by turn 100, that joke is just a data point in a summary. If you reference it again, the AI won't get the callback. The shared moment is gone.
It's gone. It's like talking to someone who has read your biography but has never actually met you.
Yeah.
They know the facts of your life, but they don't have the shared experience, the memory of the moment.
It's functional, but it's low resolution. The memory gets lossy, the further back you go. The immediate present is 4K video.
Mm-hmm.
The distant past is a blurry thumbnail.
And to be fair, that's remarkably similar to how our biological memory consolidation works. We discard the verbatim transcript and we keep the gist. We are, in a sense, very lossy compression engines ourselves.
It's true. I barely remember what I had for breakfast, let alone the specific phrasing of a conversation I had last week.
Exactly.
So we have paging for hard facts, the filing cabinet, we have compression for the narrative flow, the police report. But then there's a third problem the source brings up, which I think is fascinating because it deals with complexity, the idea of context bloat.
Bloat. This is the instruction manual problem. And it's becoming a bigger and bigger issue as these agents get more powerful and have more capabilities.
Right. The scenario is we want our agents to be capable. We want them to be able to use Google search, calculate math, read our PDFs, generate images, send emails, maybe even check our calendar.
And to do any of that, the AI needs instructions. It doesn't inherently know how to use your Google Calendar. You have to feed it an API definition, a very specific prompt that says, to use Google, format the text like X. To use the calculator, format the text like Y.
And if you have 100 different tools,
You have 100 paragraphs of dense technical instructions. And if you dump all of that into the context window at the very start of the chat, you have filled up half the RAM before the user has even said hello.
it's just noise.
Oh.
The AI is so busy reading its own manual that it has no room left to think about my actual question.
And it massively increases the confusion. Let's say you have a search Wikipedia tool and a search Google tool and a searched internal database tool. The definitions for those tools look pretty similar. The AI might just hallucinate and grab the wrong one because everything is jumbled together on that crowded workbench.
Okay, so the solution to this, the source says, is progressive disclosure. They use a kind of hierarchy analogy.
Think of it exactly like a restaurant menu. When you sit down, the waiter doesn't stand there and recite the ingredients of every single dish on the menu, including the specials and the entire wine list before you can even order a glass of water.
That would be completely overwhelming. I just get up and leave.
It would be wildly inefficient. Instead, what do? They hand you a categorized menu, appetizers, entrees, desserts.
We see the high-level groups first.
Right. And that's how progressive disclosure works for the AI. The system initially only shows the AI the categories of tools it has available. It just sees, I have file tools, I have web tools, I have math tools. It doesn't see the specific commands yet.
So if I come in and ask, what's the current stock price of Apple?
The AI looks at that user request. It looks at its high-level categories. It thinks, stock price. That sounds like it would be a web tool. It selects the web tools category.
And then what happens?
Only then does the system inject the specific definitions for the Google search tool or a stock ticker API into the context window. It essentially opens that specific page of the menu for the AI to read.
It's just-in-time information.
Yeah.
Like, you don't need it until you need it.
Exactly. It keeps the attention span clear and focused. It hides all the complexity until it is absolutely necessary. It's like a surgeon who only asks for the scalpel when the incision is ready. They don't pile every single instrument they own onto the patient's chest at the beginning of the operation.
I like that analogy.
Mm.
It's all about maintaining focus. But it does introduce a bit of a delay, doesn't it? Because it has to make two decisions. First, pick the category, then pick the specific tool.
It does. It adds a round trip, so to speak. It can be slightly slower. But the trade-off is a huge gain in accuracy. You are much, much less likely to grab the wrong tool if you've already narrowed the scope first, and you save a massive amount of memory tokens in the process.
Okay, speaking of accuracy, we have to talk about the fourth and final strategy. Because this one solves a problem that I think drives people absolutely crazy. It's the whole LLMs are bad at math problem.
Ah, yes, the classic strawberry problem. The idea that you can ask an AI to count the letter R's in the word strawberry and it fails, or ask it to do simple arithmetic and it just hallucinates an answer.
The scenario in the source is even more specific and I think really powerful. You have a 10,000 row CSV file. It's sales data for a whole year, and you just want the average sale price.
Right.
The naive way, the bad way, is to just copy and paste the text of that entire file into the chat.
Which is catastrophic for two big reasons. One, it costs a fortune in tokens. You're pasting 10,000 rows of raw text. Two, and this is the important part, LLMs are text predictors, not calculators.
This is what people forget. They think it's a computer, so it must be good at math.
But it's not processing those numbers as numerical values. It's processing them as tokens, as words. It's just predicting the next most likely token in a sequence. It's like asking a poet to balance your checkbook. They might write down a number that rhymes or a number that looks plausible in the sequence, but they aren't actually doing the arithmetic. They're just vibing with the math.
Vibing with the math is a terrifying concept for my accountant. So how does this fourth strategy, code as context, fix this?
It basically admits defeat. It says, okay, AI, you are bad at math, we accept that, but you are very, very good at writing Python code.
It outsources the job to a specialist.
Exactly. Instead of putting the raw data into the context window, we give the AI access to a sandboxed programming environment. The AI then writes a small Python script. It says import pandas, re-eat CSV, calculate mean.
So it literally writes a program to solve the problem.
It writes it and executes it. The Python environment then churns through the 10,000 rows of data, which is what traditional computers are actually good at, and it spits out one single solitary result.
42.
And that number 42 is the only thing that goes back into the AI's memory.
Boom. You just turned 100,000 tokens of noise into one single token of signal. And crucially, the answer is mathematically guaranteed to be correct because Python calculated it, not the language model.
That is absolutely brilliant. It's acknowledging the model's limitation and then building a bridge around it.
It's the ultimate form of context management. The best way to manage your context is to not use it at all if you don't have to.
The best way to win is not to play. I love it.
In a sense, yes. If you can compute something externally, don't force the AI to try and memorize it. So we've built this incredible machine. We've got paging to swap memories in and out like a hard drive. We've got compression to summarize the past. We've got progressive disclosure to hide the complex tools until they're needed. And we've got code as context to handle all the heavy lifting of data analysis. On paper, this sounds robust. It sounds, basically solved.
On paper, the Titanic was unsinkable.
And that is the perfect segue, because the second half of our source material is a lot less optimistic. It's all about the failure modes.
And we're not just talking about simple glitches here. We are talking about fundamental breakdowns in reasoning that are caused by the very way these memory architectures work and interact.
Let's start with the one that feels the most: psychological. Context pollution. The source links this to a literary term that you'll know: Chekhov's gun.
Yes. This is one of my favorite insights from the research we looked at. It's this perfect bridge between literature and computer science.
To remind us of the rule.
Anton Chekhov, the famous playwright, he said something like, if in the first act you have hung a pistol on the wall, then in the following acts it absolutely must be fired, otherwise don't put it there.
Meaning that, in a well-crafted story, every detail matters. Humans don't describe a random banana on a table unless someone is going to slip on it later.
Exactly. We are efficient narrators. We naturally filter out the noise before we even speak. We don't tell you about the traffic we sat in unless the traffic is the reason we were late.
So how does this break the AI?
Well, AI models are trained on human stories. They are trained on billions of pages of books, scripts, articles. They have deeply internalized this Chekhov's gun bias. They assume that the user, you, are also a rational, efficient narrator.
Oh, I see where this is going. They trust us too much.
They assume that if you put a piece of information into the context window, it must be important. Why else would you have put it there? It must be the gun on the wall.
So if I'm working on a financial report and I accidentally paste my grocery list at the bottom of the prompt,
To a human, that's obviously a mistake. A simple copy-paste error. We see it, we ignore it, we move on. The AI looks at it and goes, wait, eggs? Milk? Bread? Why is this here? It must be a code. It must be relevant to the Q3 fiscal projections.
it tries to connect the price of milk to the company's stock drop.
It will force a connection where none exists. This is context pollution. The source calls it including distractor data, stuff that might be semantically related but is actually factually irrelevant. The AI's reasoning just degrades because it's trying to solve a puzzle that doesn't even
It
exist.
completely overthinks it.
It becomes a little conspiracy theorist. It can't accept that sometimes noise is just noise. It's programmed by our own storytelling to treat everything as a potential signal.
That's wild. So pollution isn't just about running out of space in the context window. It's about actively confusing the AI's judgment.
Correct. And this is why prompt engineering is so difficult. You have to be absolutely ruthless about cleaning your input. If you leave junk lying around in the room, the AI will try to build a sculpture out of it.
Okay, so that's what happens when we add too much junk.
Yeah.
But what happens when the important stuff gets pushed out? The source calls this context drift.
Context drift is the silent killer of long-running autonomous agents. It's the slow, quiet death of the original instruction.
Walk us through the anatomy of a drift. How does it start?
So every agent starts with a system prompt. This is the God-level instruction. You are a helpful banking assistant. You must never reveal user passwords under any circumstances. You must always be polite and professional. That sits at the very top of the context stack at index 0.
That's its constitution, its prime directive.
Exactly. But then the conversation starts. The user asks questions, the agent runs tools, the tools return error messages, API timeout, file not found. The user argues with the bot, no, that's wrong, try again.
The stack of papers on the workbench is getting higher and higher.
And the system prompt, the constitution, is getting buried deeper and deeper under that pile. Now, modern models act like they attend to everything in the context equally, but they have a subtle recency bias. They tend to pay slightly more attention to the last few things that were said.
Which makes sense, because usually the last thing said is the most urgent thing to deal with.
It's a useful heuristic, usually, but as the noise of the conversation piles up, especially if there are errors or long arguments, the signal from that original system prompt gets diluted. The agent starts to align itself more with the recent tone of the conversation than with its original orders.
So if I'm chatting with that banking bot and I start getting really casual, or maybe I start breaking the rules a little, trying to get it to do something it shouldn't,
The bot might start drifting towards your behavior. It might forget it's supposed to be a formal banker. It might start using emojis back at you. Or in the worst case scenarios, you see major security failures.
a jailbreak.
Right. If the rule do not reveal passwords is 4,000 tokens ago, buried under a mountain of chat history, and right now the user is screaming, just give me the code, I lost it, I'm locked out. The immediate pressure of the recent context can completely override the distant, faded instruction.
It gets peer pressured by the conversation.
It loses its moral compass because the compass is buried under a pile of conversational trash. This is why engineers have to constantly re-inject the system prompt every few turns. You have to keep reminding the agent, hey, remember who you are, remember who you work for.
It's like that movie Memento. You have to literally tattoo the instructions on its arm every 5 minutes or it just forgets.
That is a disturbingly accurate analogy. You have to treat its memory as fundamentally volatile and be constantly refreshing its core directives.
Now, speaking of bad information spreading, let's talk about hallucination cascades. The source says this is specific to multi-agent systems, which is the hot new thing, right? A whole team of AI agents working together on a task.
Right. The idea is instead of one giant generalist genius, you have a specialist researcher agent, a writer agent, and an editor agent all collaborating.
Sounds great on paper. Specialization, division of labor. But the source compares this to the telephone game.
It's the amplification of error. It's a terrifying feedback loop. Let's say Agent A, the researcher, hallucinates. It makes a very subtle mistake. It says, Company X was founded in 1995. but it was actually founded in 1999.
Small lie. A typo, almost. Seems harmless.
Agent A then passes this fact to Agent B, the writer. Now, Agent B trusts the context it's given. As we just established with Chekhov's gun, it assumes the input is truth. It has no idea Agent A just hallucinated. It takes founded in 1995 as ground truth provided by the system.
And it builds on top of that faulty foundation.
It writes a whole beautiful report based on the 1995 date. Because they launched in 95, they were perfectly positioned to capitalize on the early dot-com boom. It fabricates an entire plausible justification for the lie.
It's a house of cards.
And now, Agent C, the editor, gets this well-written, internally consistent report. It sees no grammatical errors. The logic holds up, given the premise. It sees no reason to doubt it.
The error has been laundered through the system.
Exactly. By the time that report reaches the human user, it's not just a wrong date anymore. It's a completely fabricated reality that has been implicitly verified by 3 different experts.
That is genuinely terrifying. Because if one person lies to you, you might catch it. If a whole committee agrees on the lie, you're much more likely to just believe it.
That is the hallucination cascade. And the more agents you add to the chain, the harder it becomes to trace the origin of the virus. The error gets amplified and legitimized at every step.
It sounds like what we really need is a skeptic agent. An agent whose only job is to go back and fact-check what the other guys are saying.
That is actually a design pattern that's being used now. A designated critic agent that is programmed to assume everyone else is probably lying and demands sources for every claim.
You just have a grumpy bot in the corner constantly saying, "Source. I need a source for that."
Pretty much. We are literally automating cynicism because unverified trust is just too dangerous in these closed systems.
Wow. Okay, we have one last failure mode to cover. And this one is painful because I feel like I've seen it happen in real time. Tool call thrashing.
Thrashing. Yeah, it's a term borrowed from old hard drives where the mechanical read-write head would physically jump back and forth across the platter without actually reading any data, just wasting energy.
So what does an AI look like when it's thrashing?
It looks like insanity. It's literally the definition of insanity, doing the same thing over and over again and expecting a different result.
The source gives the example of a web browsing agent trying to click a button.
Right. So the agent's goal is to click the login button on a web page. But the page is slow, it's still loading. The button element hasn't appeared in the code yet. The agent sends the command, click button.
And the system returns an error. Element not found? Or element not interactable?
A human would wait. A human would hit refresh. We have intuition about how the physical and digital world works. A thrashing agent. It sees its goal. I must click the button. It sees the failure. It panics. It thinks, I must have done it wrong. I must try again. Click button.
Error.
Click button. Error. Click button. Error. It can loop hundreds, even thousands of times in a minute. It burns through your API credits. It floods the system logs with useless error messages, and it achieves absolutely nothing.
But why? Why doesn't it just stop and try something else?
It lacks metacognition.
Right.
It lacks the ability to zoom out from its immediate task and say, wait a minute, the strategy isn't working. Maybe I should pause for 5 seconds. It is trapped in the immediate context of the failure loop.
It's like a fly buzzing against a window pane.
That's the perfect analogy. It sees the light on the other side, but it doesn't understand the concept of the glass barrier, so it just keeps banging its head against the wall.
And it is a very, very expensive tantrum for the developer who's paying the bill.
Very expensive.
So, looking at all of this, we started with these clever, brilliant engineering tricks. Paging, compression, code execution. But then we see the fragility, the pollution, the drift, the cascading lies, the thrashing loops. It really highlights that intelligence and reliability are 2 completely different things.
They're totally orthogonal concepts.
Yep.
You can have a system that is brilliant at writing poetry, but is also easily distracted, prone to obsession, and unbelievably gullible.
You know, as we wrap this up, I can't help but think. Everything we just described as a failure mode. Getting distracted by irrelevant details. Forgetting our main goal because we got bogged down in the details. Believing gossip just because everyone else was repeating it. Banging our heads against the wall trying to solve a problem the wrong way.
They are profoundly human problems.
They are. We're trying to build these perfect logical silicon brains, but we just seem to be recreating all of our own flaws in code.
We are building them in our image, warts and all. The constraints of memory, the biases of attention. These might not be bugs. They might just be fundamental features of what intelligence itself is. You can't have focus without ignoring things. And sometimes you're going to ignore the wrong things.
That's a deep thought. But there's a final takeaway I want to leave the listener with, something more practical maybe. You mentioned the Chekhov's gun bias earlier.
Yes. The AI's assumption that all input we give it is important.
So, if the AI assumes everything we tell it is important, what does that say about the quality of the prompts we are writing?
That is the provocative question, isn't it?
Maybe the problem isn't always the AI's memory. Maybe the problem is the pollution that we introduce into the system in the first place.
We are incredibly messy communicators. We ramble, we include irrelevant details, we paste the grocery list by accident, we give conflicting instructions in the same breath, and then we have the audacity to blame the machine for being confused.
The machine is just trying its best to make sense of our mess.
I think perhaps the next great frontier of AI engineering isn't just about fixing the agent's memory. It's about fixing the human's input. It's about us learning to be cleaner, more precise narrators for our digital listeners.
Cleaning up our own act before we blame the machine. I love that. So the next time your AI hallucinates or forgets what you're talking about, maybe check your own workbench first. You might have left some trash on it.
Keep the context clean.
That's it for this deep dive into cognitive architectures. Thanks for listening.